week. So we talked a little bit about how we make sure we rehydrate with sodium and potassium and how sugar dehydrates us. Today we're going to go back into the basics and just understand what the whole function of the urinary system is and basically how it works. So our main question today is, how do you form urine? To do that, we're going to just first quickly review the kidney structure and the basic function. Then we'll go through the 3 steps in how we form urine, and that's glomerular filtration, tubular reabsorption, and tubular secretion. All right. So function. Yes, our urinary system forms urine, but why? Why do we need to form urine? Yep, to get rid of waste. Where's that waste coming from?
The blood.
Your blood. Yep. So, really, when you look at forming urine, it comes from filtering out your blood, right? The whole job of the urine is to get rid of the waste, but the waste comes from the blood. So really, what your urinary system is trying to do is regulate your body fluids, right? The main one being blood. So what you're going to do is you're going to check your blood, make sure the volume's okay, make sure the composition is okay, make sure the pH is okay. And if it's not, that's where you get your urine waste, right? To help you, again, regulate that blood. So, of course, the waste that you want to get rid of, you excrete. So the urinary system is going to do excretion. And then lastly, we're not going to talk about this today because we've already discussed it, but remember the kidneys play an important role in erythropoiesis. Do you guys remember what erythropoiesis means?
Creating blood.
What are we making?
Red blood cells.
Red blood cells, right? Erythrocytes, which are red blood cells. And remember, that's a great place to monitor because all of the blood goes through the kidney. So you check and make sure, hey, do I need to make new red blood cells? And it's also a great place to actually help control blood pressure because, again, the blood is coming through the kidney, so you can, again, monitor and regulate the blood. All right, so our goal is we're going to basically filter through the blood and form and excrete our urine. To do that, we've got 2 kidneys. We've got 2 ureters coming out of the kidneys. We've got 1 urinary bladder, and then 1 urethra to exit the waste. So quick kidney anatomy review. They're retroperitoneal. Remember, that means they're behind the peritoneum membrane. So they're on the posterior part of the abdominal wall. They're at about the level of T12 to L3. So do you guys remember what T stands for? Yep, thoracic. So remember the 12th thoracic vertebrae, right? You have 12 thoracic vertebrae. And what does L stand for? Lumbar. So they go to about the 3rd lumbar vertebrae. Or in other words, your kidneys are about the size of your hand. If you were just to kind of rest them comfortably on your back like this is about the location of my kidneys. So this would be T12, and that would be L3. Okay, so here's a little cartoon blow-up of the kidney. Of course, our job is to filter blood, so you want to make sure you have a good blood supply going in and out of the kidney. Remember, the renal artery is the main artery going into the kidney. The renal vein is the main vein bringing blood out of the kidney. Okay. If you look at the kidney, you can break it down into 3 main regions. So you've got the outer region of the kidney, called the cortex. You've got the middle region of the kidney called the medulla. And then you have the inner part of the kidney called the pelvis. Now the majority of our blood filtering and our urine formation is happening in the cortex and the medulla. Okay, so that's where we're going to filter our blood and make our urine. Once we make our urine, we're going to bring all of the urine to the inner part of our kidney called the pelvis, and notice the pelvis is going to empty into our ureter. So by the time we get to the pelvis, which is this yellow area, that's the urine you know that you're going to urinate out. So it just goes down the ureters, into the bladder, and then out the urethra. All right, so here are the blow-up of just the cortex and the medulla, so the outer and middle region of the kidney, which is where we're filtering our blood and making our urine. If you look, you'll see all of these tiny tubular networks in yellow. That's called the nephron. So each kidney has probably about 1 million nephrons in it. And the nephron is where we're going to spend all of our time today because it's this nephron that's going to be doing all the filtering of the blood and all the making of the urine. So imagine you've got these little nephrons in each kidney, and each nephron is filtering blood and making urine. So let's see if you guys remember from anatomy. Nephron is just a bunch of tubes. Do you guys remember which is the correct order of the kidney tubules in the nephron? PCT, which stands for proximal convoluted tubule. DCT, which stands for distal convoluted tubule. So which order is correct? PCT, DCT, and then the loop of Henle? DCT, loop of Henle, then the PCT, or the PCT, loop of Henle, then the DCT? What do you think? 1, 2, or 3? Okay. You might need a little anatomy review. Okay, let's first of all get a hint. What does proximal mean?
Close.
Closest. Proximal is actually then going to be the first. Proximal is the closest. What does distal mean?
Far.
Far. So distal is actually going to be the last. Right? And the loop comes right in the middle. Alright? So knowing that, which one is it? 3. Yeah. So number 3. So we're going to start with the proximal because it's the closest. Then we go to the loop. Then we do the distal, which is the furthest. Okay. So to help you review a little bit of the anatomy, because if you don't understand the basic anatomy, it's going to be hard to do the physiology, I got this little handout that we'll work through together. It's also posted on Canvas, but what this is basically a cartoon version of a nephron. And what I want you guys to do in this first is you can label your tubule. So there's going to be a proximal convoluted tubule, which is here. The loop of Henle, which comes down, a distal convoluted tubule, and then after the distal convoluted tubule, you have your last collecting duct. All right? So you want to label those, and then notice up here I have a glomerular capsule, which is actually the first part right before the proximal convoluted tubule, and then the glomerulus. The glomerulus is the blood that's going to come in. All right? So I'm going to give you guys this handout. Can work in probably one for every 2 or 3 people. And again, the first thing you want to do, directions are also on the back, but also up here. First thing is just do a quick anatomy review, label those 6 structures.
Do you want to label it yourself?
And again, this is also on Canvas for you guys to look at.
You don't remember anything? She just pointed at it, remember? So you this? Okay. So, remember she said this is the proximal convoluted tubule, distal, the loop of Henle, collecting duct, glomerulus, capsule, and then the glomerulus is the blood that goes inside the capsule. Okay. So she said proximal convoluted tubule, distal convoluted tubule. This is the loop of Henle. This is the collecting duct, glomerulus capsule, and then the glomerulus is the blood that's going in. I guess I don't